Hello, this is the last piece for the derivative and integration section. I'm going to show you some computer programs. I am working in the Xcode environment on my Mac as I'm programming. You can use the GCC, which is free. You can download a text editor. You could write the program in a text editor and you can send it to the GCC if you're doing C programming. You could also download NetBeans. NetBeans should allow you to do both C and Java if you get the correct plugins. And NetBeans is free the last time I looked. So you don't have to use any proprietary kinds of things. Xcode just comes with my Mac, and that's why I'm done. Or I'm doing this. First thing I'm going to do is, of course, I'm going to do first derivative approximation. You have to create a project, and what I do is I just want a console program. So it's going to name the project, and then it creates a console, and it calls it main.cpp within the project. This is just the first derivative done three ways. It puts my name up at the top. The IO stream is just the input-output package for this. All right, so I have to load how to do input and output. And I want the math header, right, just because I want the ability, if I'm going to change the function that it's going to use to sines and cosines or exponentials, that I have that ability. I pre-declared the function up here, and then I put it at the bottom, right, because that's how I learned how to program in C way back when. I could have just put the whole thing at the top. It doesn't really matter. It would save me typing if I just put the whole thing at the top. But I'm an old style procedural programmer, so I kind of go with what I know and sort of tack things on as I get better. The main is your main part of your program. Right? It runs from here to there, from the int, that's integer main. And all it's going to do is it returns a value, in this case 0. That tells your operating system that I'm done now, you can quit. And it terminates correctly. It does not crash. If you return anything else other than a 0, well, it depends on your operating system. But in a Mac, if you return anything other than a 0, it will tell you that the program crashed. There was abnormal termination of the program. If you remember from the very first chapter, there's precision. And to get better precision, you have to declare your variables at a certain level. Float is not going to do it. Floating point operations are not good enough here. Double means double precision, double floating point precision. Right? So you need all of these variables to be double. Right? Notice that X, H, backward, forward, and central, I'm either inputting those or they do the calculation right up front. So I don't have to worry about initializing those. But I do want X minus and X plus to be initialized. It would be a really good thing if I initialized every single variable, because otherwise it just picks out memory space. And if there is already garbage there for some reason, it just gets loaded into my variable at that point, which is a really, really bad thing and will cause you problems if you're not careful. All right, so I heartily recommend for high precision programming, or if you're writing programs for high precision output and data analysis or any kind of analysis, that you initialize all your variables. I just got a little sloppy here. All right. The cout, of course, is just going to output this thing to the screen. It says, please input the step size, right? And then I go C in H. Then it please input the X value, and I see in the X, that's the value about which I wish to do this derivative, right? Then, of course, it's just X minus is X minus H, X plus is X plus H. It sort of follows what I did in the spreadsheet. To be quite honest, the spreadsheet follows the program. I did the program first. And then I just do the backward approximation here. I take f of x and I pass it x minus. minus f of x, and I pass it x, and I divide by h. And then the backward approximation is, and it spits out the answer that I get. Forward, I pass it x plus, I pass it x, it does the computation, and I spit that answer out. And central approximation is just fx, x plus, minus fx, x minus, divided by 2 times h. All right. And down here where it says double, right, because this declaration tells me what the function is going to pass back, and I definitely want it to pass back a double value, a double precision value. And this double x tells me what I'm passing the function, and I'm passing it a double precision value. And I just put the actual function right here. All right, so right inside the return statement, it does the computation first and then returns that value. All right, so here's the only thing you have to change. You change everything inside those parentheses to what you want to compute. Say it's x times sine x, it will do it. E to the minus x over 10, it will do it. All right, so all you have to do is plunk it right in there. So really, to keep running this program, you just have to keep changing this, right, for all the different functions that you want, and you're good to go. Pretty straightforward as far as writing the program goes. For a first derivative, I didn't do a second derivative piece to this. I could tack on just a couple extra lines. If I remember to do that, I will. I'll include it in the program. If not, if you are a programmer and you want to write the program as part of your homework and the projects for this particular module, then please feel free to do so. Don't write it from scratch. Take my program, alter it however you need to alter it, and then go ahead. Some of you are very much object-oriented programmers because that's the way you learned, and you would take all of this and create a whole separate module for that, so that you could pass parameters back and forth. Do whatever it is that you think you need to do to make it the most efficient for what you want it to do. Now, for numeric integration, I also wrote a program. And again, I didn't just pre-declare the function, I actually stuck the function right up front. All right, so I do this several different times, if you notice. I've got a float, an f of x, right? So really what you have to do, again, is just change what's in here, right? What's in the return statement. Here it's 3x squared plus 2x minus 5. You could do it x times sine x, you could do it whatever. I omitted the parens, and that's fine. It will work, and it has no trouble doing that. It's better form to actually put the parentheses in, but again, doesn't matter. But what I now do is I've also done trapezoidal and Simpson equation. Right? So if I'm doing trapezoidal integration, notice it's a float, not a double. I should make all these double, really. But I was trying to do this quick and dirty, right? So, and you can tell, right, it shows up. I will not get the same precision here with float that I do if I made all these double. Right? So I would absolutely suggest to you that if you are using this particular program to do what you want it to do, I would change all the floats to doubles. And that will give you better precision and better accuracy. Notice I do at least remember to declare and set all my variables equal to 0. It does compute the h to b minus a over n. All right, but I have to pass it n, a, and b to do that. It does the sum, and then it goes through a for loop where it just goes from I equal 1 to n minus 1. The I++ just increments I, which is your counter. That's why that thing can be integer, right? Because it's just an integer counter. The x plus equals h is just a shorthand way of saying x is equal to x plus h. Right? So you take h, add it to x, and then store it back as a new x value. C++ allows you to do, C actually allows you to do that. And I do the same thing with sum. It's just a running total. All right, to do everything. All right, so I have evaluated this thing at A. I have evaluated this thing at B. And then I do all the intermediate values. And then it spits the whole thing out at the end. The Simpson equation, I do exactly the same thing. You initialize it. Notice I cut and pasted because it looks very, very similar. And you know, this changes to 4 times f of x in here. Sorry about that. My volume is up too high. And then I have the sum, and then it adds. It's a different weighted sum, and then it just returns that value. I include the IO stream. I don't include the math header because I only did the 3x squared plus 2x minus 5. I should include the math header in here as well. So I will need to include it if I'm doing exponentials or sines and cosines. So I will need that include math.h. And then I'm here and I just, you know, this is going to be an integer. That's my number of intervals. You cannot have a fractional number of intervals. Then this is your bounds, your A and your B. Again, that should probably be double. Right? And you want to know the number of intervals, the left bound, the right bound, right? And then it spits out the 2 answers for you. So those are my 2 programs. The second one, the integration program, could be improved. Again, it is just a quick and dirty example, but it does run and it does give you some results. I think if I changed all the floats to doubles and I ran it twice, I ran it once as float, I ran it once as double, even if I left the intervals and the bounds the exact same, I would get different answers simply because I had different levels of precision. So I would change all the float to double, but I was just trying to get this out the door so that you could see it. So again, these should be available to you. You can change them however you need. Again, change the name in the program statement. And you should be able to use, if you're a programmer and you want to do this, you should be able to use these to do your homework and the projects for this module. Thank you very much.